FPV drone tuning is crucial for optimal performance. Without proper tuning, your drone may not respond as expected, leading to a less enjoyable flying experience. A well-tuned drone feels locked in, responsive, and predictable. This means that every input you make on the controls translates accurately to the drone's movements. This allows pilots to push their limits and explore the full potential of their aircraft. You can navigate through tight spaces, perform complex maneuvers, and race with confidence. Whether you're a beginner or seasoned pilot, understanding the tuning process is essential. It helps you get the most out of your drone and ensures a safer, more controlled flight. This guide will provide a step-by-step approach to tuning your FPV drone using Betaflight. We'll cover everything from initial setup to advanced tuning techniques. Betaflight is a powerful, open-source flight controller firmware. It's widely used in the FPV community for its versatility and extensive features. It offers a wide range of customizable settings. You can adjust parameters to suit your flying style and the specific requirements of your drone. These settings allow you to fine-tune your drone's behavior. From how it handles in the air to how it responds to your inputs, you have full control. From basic adjustments like rates and PIDs to advanced filtering options, Betaflight puts you in control. You can tweak every aspect to achieve the perfect flight characteristics. By the end of this guide, you'll have the knowledge and confidence to tune your drone like a pro. You'll be able to make precise adjustments and enjoy a superior flying experience. Before diving into tuning, gather the necessary tools. You'll need a computer, a USB cable to connect your drone, and Betaflight Configurator. Betaflight Configurator is a free software available on GitHub. It provides a user-friendly interface for accessing and adjusting your drone's settings. Once you have the tools, connect your drone to your computer. Open Betaflight Configurator. It's essential to back up your current settings before making any changes. This ensures that you can revert to a stable configuration if needed. To back up your settings, go to the CLI tab in Betaflight Configurator and type dump, then press enter. Save the resulting text file. Rates determine how fast your drone rotates around its axis. Roll, pitch, yaw. Higher rates result in a more responsive and agile drone. Lower rates provide a smoother and more stable flight experience. Finding the right rates is subjective and depends on your flying style and preferences. Start with Betaflight's default rates and adjust them incrementally. Increase rates if you want your drone to feel more responsive. Decrease rates if you prefer a smoother, more predictable feel. It's crucial to test your adjustments in a controlled environment such as a simulator or an open field. Pay attention to how your drone feels during turns, flips, and other maneuvers. PIDs, or proportional integral derivative, are the heart of your drone's flight controller. They govern how the drone responds to your control inputs. PIDs ensure that the drone maintains stability and follows your commands accurately. Each PID setting, P, I, and D, influences a specific aspect of flight control. P, or proportional, controls the immediate response to a change in input. I, or integral, corrects for long-term errors and drift. D, or derivative, dampens oscillations and improves stability. Tuning PIDs can seem daunting, but it's a crucial step towards achieving optimal drone performance. Begin with Betaflight's default PID values. Section 5. Filtering, smoothing out the rough edges. Filtering is essential for minimizing noise and vibrations in your drone's sensor data. This results in a smoother and more stable flight experience. Betaflight offers various filtering options, each targeting specific frequencies and noise sources. Proper filtering can significantly improve your drone's handling, especially during high-speed flights and maneuvers. Start by enabling the default filtering settings in Betaflight. These settings provide a good balance between noise reduction and responsiveness. If you experience oscillations or jitter in your drone's movements, you may need to adjust the filtering settings. Increasing filtering can reduce noise. However, excessive filtering can make the drone feel sluggish and unresponsive. Section 6. Battery settings, powering your flight. In this section, we will delve into the crucial aspects of configuring your battery settings to ensure optimal performance and safety during your flights. Configuring your battery settings correctly is essential for both performance and safety. Proper settings can significantly enhance your drone's efficiency and longevity. Betaflight allows you to set the battery voltage cutoff and capacity. These settings are vital to prevent over-discharging, which can damage your batteries and reduce their lifespan. This helps prevent over-discharging your batteries and ensures accurate flight time estimation. By monitoring these parameters, you can avoid unexpected power loss during critical moments of your flight. To configure your battery settings, navigate to the Power and Battery tab in Betaflight Configurator. This tab provides all the necessary options to fine-tune your battery parameters, input your battery's capacity in milliamp hours, and set the voltage cutoff. The capacity value helps Betaflight calculate the remaining flight time accurately. The voltage cutoff should be set to a safe level to prevent damaging your batteries. Setting it too low can lead to over-discharging, while setting it too high might reduce your flight time unnecessarily. A common value is 3.3 volts per cell. This value strikes a balance between preserving battery health and maximizing flight duration. Betaflight will display your estimated flight time based on your battery settings and current consumption. This feature allows you to plan your flights more effectively and avoid mid-air surprises. Keep an eye on the battery voltage during flight to avoid unexpected landings. Regular monitoring ensures that you can bring your drone back safely before the battery depletes completely. Section 7. Fail-safe, preparing for the unexpected. A fail-safe system is crucial for minimizing damage in case of a signal loss or other unexpected events. Betaflight allows you to configure a fail-safe procedure that will activate if your drone loses connection with the transmitter. You can choose to have your drone disarm its motors, hold its current position, or return to home automatically. To configure your fail-safe settings, go to the Fail-Safe tab in Betaflight Configurator. Select your desired fail-safe mode and configure any relevant settings, such as the return to home altitude and GPS rescue mode. It's crucial to test your fail-safe system in a controlled environment to ensure it's working correctly. Section 8. Advanced Tuning, pushing the limits. Once you're comfortable with the basic tuning settings, you can explore Betaflight's advanced features to further enhance your drone's performance. These features include feed-forward, dynamic notch filtering, and anti-gravity settings. Feed-forward improves your drone's responsiveness by predicting future motor output based on your control inputs. Dynamic notch filtering automatically identifies and reduces resonant frequencies, resulting in a cleaner and more stable flight. Anti-gravity compensates for variations in motor thrust due to gravity, improving overall flight stability. These advanced settings require a deeper understanding of flight dynamics and should be adjusted incrementally. It's essential to thoroughly test each adjustment and observe its impact on your drone's behavior. Section 9. Testing your tune, from simulators to the field. This is where all your hard work in the simulator pays off. Testing your tune is crucial to ensure that your drone is flying optimally. A well-tuned drone will respond accurately to your inputs and provide a smoother flight experience. Start by testing in a simulator. This step is essential because it allows you to make adjustments without risking damage to your actual drone. Simulators provide a safe and controlled environment to experiment with different settings and practice maneuvers. You can try out various configurations and see how they affect your drone's performance. Once you're satisfied with your tune in the simulator, it's time to head to the field. This transition is crucial, as real-world conditions can differ significantly from the simulator. Choose an open area free from obstacles and people. Safety should always be your top priority when flying your drone. Perform a series of test flights, gradually increasing the intensity and complexity of your maneuvers. Start with basic movements and slowly progress to more advanced tricks. Pay close attention to how your drone feels during each maneuver. Notice any delays in response or unusual movements. Look for any signs of instability, oscillations, or unexpected behavior. These issues can indicate that further tuning is needed. After each flight, analyze your drone's black box data if available. This data can provide valuable insights into your drone's performance and help you make precise adjustments. Section 10. Regular maintenance. Keeping your drone in top shape. Regular maintenance is essential for ensuring consistent drone performance and longevity. Inspect your drone before and after each flight. Check for any loose screws, damaged components, or signs of wear and tear. Keep your drone clean and free from dirt, debris, and moisture. Replace any worn-out or damaged parts promptly. Regularly calibrate your drone sensors, including the accelerometer, gyroscope, and magnetometer. Keeping your drone in top shape will not only improve its performance but also extend its lifespan. By following these maintenance practices, you can enjoy countless hours of enjoyable and safe FPV flights. Section 11. Conclusion. Mastering the art of drone tuning. Mastering FPV drone tuning is an ongoing journey. It involves understanding your drone's mechanics, experimenting with settings, and adapting to different flying conditions. By following the steps outlined in this guide and dedicating time to practice, you can unlock your drone's full potential and achieve a truly rewarding flight experience. Remember that tuning is an iterative process. Don't be afraid to experiment and fine-tune your settings to match your flying style and preferences. With patience, persistence, and a passion for FPV flight, you can master the art of drone tuning and elevate your skills to new heights.